Dude, check this out. Most years, if you're into astronomy, you're lucky if you get 1 or 2 comets rolling through the inner solar system. That's kind of the norm. Maybe 3 if the sky surveys are on a hot streak. But late 2025, man, it's like cosmic rush hour out there. 7 big comets all diving in at the same time. 7. That's insane. Astronomers are already calling it the wildest traffic jam the solar system has seen since we had telescopes, good enough to track this stuff systematically. And it's not just some random little ice balls either. One of them, 3I, Atlas, is a straight-up heavyweight. And get this, it's not even from our solar system. It's interstellar, just passing through like some cosmic tourist. That alone would have been front-page news in any normal year. Like, if you told astronomers 10 years ago, hey, we've got a big interstellar comet swinging by, they'd be camping outside with every telescope they could get their hands on. But now, we've got that plus 6 other major comets in the same 6-month stretch. It's like the universe just stacked the deck to mess with us. And people are asking the obvious questions. Why now? Why so many at once? And should we be worried? Because comets aren't just pretty tails in the sky. These things are unpredictable. They can break apart, flare up brighter than expected, or in some cases, just barely miss us. And when you've got 7 in play at once, racing around the sun, weaving past Earth, that's a lot of moving parts in the system. Some astronomers are even wondering if all this action could mess with solar storms, like maybe the dust and debris feeds into the sun's magnetic activity. That's speculation, but still, it's wild to think about. Now, to put this into perspective, since 2000, the average year gives us maybe 1 comet that's bright enough for regular people to actually see with their own eyes. 1. And then you might have 2 or 3 that you can pick up with binoculars or a telescope. That's it. A lot of years, honestly, are just duds. Faint little fuzzballs only hardcore astronomers care about. But this, 7 in a row, all crammed into one season, that's basically unheard of. And it's not just the number, it's the timing. Usually, comets show up spread out over years, a trickle. This is a swarm, one after the other, like a cosmic parade. And what's really messing with the experts is how rare this alignment island. According to the Minor Planet Center's logs, we haven't had anything close since telescopes went digital. Back in the old days, when discoveries were literally word of mouth and photographs on glass plates, you might have had stretches where multiple comets were discovered close together. But in the modern era, with systematic surveys like Pan-STARRS, Linear, Atlas, nope, nothing like this, the record says 4 in a season was the max. This year, we're blowing past that to 7. And here's the kicker. Even with all our fancy robotic telescopes scanning the skies, most of the new comets we find are duds. They're too dim, too far, or they break apart before they do anything exciting. Bright comets, the kind people still remember years later, like Hale-Bopp in the 90s, those are rare. Astronomers sometimes go a whole decade without one worth talking about. And now we're looking at 7, with at least one almost guaranteed to flare up bright enough that you'll walk outside, look up, and go, holy shit, that's a comet. So, yeah, buckle up. 2025 isn't just giving us political chaos and weird weather. The universe decided to throw in a cosmic light show, too, one we haven't seen in living memory. The 2025 comet swarm is so weird that astronomers are calling it a statistical outlier, like one of those once-in-many-generations type deals. That's how rare it island. Normally, comets are like solo artists. They show up one at a time, maybe a couple overlap if you're lucky. But this is a full-blown music festival lineup, and the solar system's the stage. You've got 7 headliners all crowding in together, each with its own wild orbit, and scientists are treating it less like a set of individual comets and more like one giant multi-act event. And here's the fun part. They're not just asking, okay, how bright will this one get, or where can we see it from Earth? They're looking at the choreography, man. How the orbits overlap, how the timing lines up, how each one interacts with the sun, like we're about to watch a bunch of icy ancient travelers dance through a gravitational rave. And because it's such a rare convergence, the excitement isn't just in the science circles. People are already talking about this like it could be the biggest naked eye comet season anyone alive has ever seen. So let's actually walk through the lineup because it's wild. First up is C, 2022 N2 Pan-STARRS. This one kicks things off in July, reaching its closest point to the sun on July 31st. But don't expect fireworks. It's way out at 3.8 AU, which means it's hanging way beyond Mars. Out there, the sunlight's weak, so only the really sensitive telescopes will pick it up. Basically, Pan-STARRS is the quiet opening act, a little warm-up before the chaos. Then in September, we get C, 2025 R2 SWAN. Now this is where it gets spicy. Discovered on September 11th, and boom, the very next day, it's already at perihelion, only half an AU from the Sunday. That's inside Earth's orbit. And on October 21st, it swings past Earth at just 0.25 AU, around 37 million kilometers. In space terms, that's a close shave. This thing's going to streak across the sky pre-dawn in the northern hemisphere. It's moving fast, it's brightening quickly, and astronomers are hyped because it'll give them a front row seat to watch how a comet interacts with both Earth and the Sun almost at the same time. Next up is 414p stereo. This one does its thing on September 27th, coming within about 0.52 AU of the Sunday, but here's the catch. Its orbit dips below the ecliptic plane. So from Earth, it's tough to see because it gets lost in the solar glare. That's where spacecraft like the Stereo mission come in. They're literally designed to stare at the sun and catch stuff like this. So while you and I might not see it with backyard telescopes, NASA's going to get some sweet close-up footage. After that comes a beast, C, 2025 Cone Atlas. Perihelion on October 8th at just 0.33 AU. That's closer than Mercury ever gets to the Sunday Imagine. The roasting it's going to take. When comets dive in that close, they can get super dramatic, sudden outbursts, crazy tail activity, maybe even fragmentation. It's risky for the comet, but for us, it's like front row fireworks. Atlas could be one of the highlights of the whole swarm, just because of how extreme that close pass island. And then the headliner 3i Atlas, the interstellar visitor, this one's not even from around here. It's like an alien road tripper passing through our backyard. It hits superior conjunction on October 21st, which means from Earth's perspective, it's right behind the sun, so we can't see it. But then on October 29th, it makes its closest approach to the sun at 1.36 AU, just inside Mars's orbit. And with an inclination of about 5 degrees, it's cruising pretty close to the same plane as the planets. For a few days, it'll be in the mix with SWAN, both lined up in positions that are perfect for studying how comets interact with the sun's magnetic field. Even if it's not easy to see, the science payoff is huge. Then there's C, 2025 A6 Lemon, peaking on November 8th at half an AU. This one's a crowd pleaser, evening sky, post-sunset, nice and visible for northern hemisphere stargazers. Forecasts say it could hit magnitude 4, maybe even 3.5, which means naked eye visibility in dark skies. That's the kind of comet where regular people who don't own telescopes step outside, glance up, and go, whoa, that's a comet tail. Those are the ones that stick in memory. Finally, wrapping it all up is 240p, NEAT, on December 19th. This is the old-timer, a periodic comet with a perihelion at 2.12 AU. It's farther out, not super bright, but it's like the punctuation mark at the end of the season. By then, the inner solar system will have been absolutely buzzing with comet activity for 6 months straight. Now, here's why all this matters. Comets aren't just space rocks with tails. They're little laboratories of physics and chemistry, like time capsules from the early solar system. And when they dive in close to the sun, they start doing crazy stuff. The sun heats the nucleus, gas vents out, dust gets blown away, and you get two tails, one made of dust, broad and pale, and one made of ions, bright blue and super thin. The ion tail is like a live wire plugged straight into the solar wind. And sometimes that tail just snaps off. It's called a tail disconnection event. And it's one of the coolest, most dramatic space phenomena you'll ever hear about. Basically, the comet's cruising along through the solar wind, and then boom, it runs into a magnetic storm, like a coronal mass ejection or one of those giant wavy current sheets in the heliosphere. The solar magnetic field rotates hard, maybe 90 degrees in just a few minutes, and the comet can't adapt. The plasma bubble around it just rips apart. The old tail floats away into space like a ghost, and instantly, a new tail starts growing in the new direction of the solar wind. We've actually seen this happen. In April 2007, the Stereo spacecraft straight up caught a CME slamming into Comet Encke. The footage looks like science fiction. The tail gets chopped off and drifts away while the comet keeps flying like nothing happened. Stuff like that is why astronomers are so amped about this swarm. With 7 comets all weaving near the sun in just a few months, the odds of catching multiple tail disconnections, outbursts, and interactions are way higher. So yeah, this isn't just another year of skywatching. This is the kind of season scientists dream about, and the kind regular people are going to remember for the rest of their lives. So picture this. April 2007, NASA's Stereo spacecraft is out there doing its thing, keeping an eye on the sun, when a coronal mass ejection, a giant solar sneeze, smacks straight into Comet Encke, and boom. The ion tail snapped off like somebody just cut it with cosmic scissors. You literally see this gap open up right behind the comet's core, and the old tail just drifts away like some ghostly ribbon in space. Meanwhile, a brand new tail instantly starts growing in the new direction of the solar wind. Textbook physics, magneto, hydrodynamics, the whole deal playing out live in space, almost frame for frame like the computer models said it would. That's the kind of thing astronomers dream about catching. Now, these tail disconnection events aren't some once-in-a-millennium fluke. They actually happen fairly often during solar maximum, that peak in the sun's activity cycle where it's just burping out CMEs like crazy. And here's the kicker. Late 2025 is smack in the middle of solar maximum. So with this incoming parade of comets, all swinging close to the ecliptic, basically the same flat plane where the planets orbit and where solar storms are strongest, the odds of catching not just one, but multiple live disconnections, sky high. The cool part is the contrast between the two types of comet tails. The ion tail, that skinny electric blue streak made of charged particles, is the one that reacts violently to magnetic chaos. That's the one that gets lopped off and regrown when the sun's field flips out. But the dust tail, totally different game. That one's controlled by sunlight pressure and gravity. It bends in these wide, sweeping arcs. Usually it just does its thing, nice and steady. Only the most powerful CMEs can mess with it, like stripping away part of the coma or blowing off chunks of dust. So if you're out there watching with binoculars or even just your eyes, the ion tail snapping and regrowing is the showstopper. The moment where you're literally seeing the sun's invisible magnetic field written across millions of kilometers of space. Now, not everyone agrees on what these comets actually mean for the sun itself. Behind the scenes, there's a pretty spicy debate happening in the heliophysics community. On one side, you've got groups like NASA's CCMC modeling team. They're running these massive magnetohydrodynamic simulations, and what they're saying is wild. When a comet dives through the sun's magnetic environment, it's not just a passive little snowball getting fried. They argue the comet's plasma, all that gas and ionized material it sheds, can actually poke at the solar wind, maybe even nudge it into spitting out more eruptions. In their models, the magnetic field lines literally drape around the comet, get bent out of shape, and if a CME comes blasting through at the right angle, snip tail gone, sometimes within minutes. And they suggest that with several big comets cruising through at once, you might even see this cascade effect, with excess plasma seeding new instabilities in the solar wind. In plain English, comets could make the sun act spicier than usual. But the other camp isn't buying it. Teams working with the Parker Solar Probe and Solar Orbiter, these are the missions actually flying through the solar wind right now, taking direct measurements. They're like, hold up. Our data doesn't show comets flipping switches on the Sunday. They've cataloged tons of comet encounters and tail wobbles, and most of the time, the disruptions are way smaller than the models predict. Instead of dramatic cutoffs, you just see little kinks, bends, or subtle twists in the tails. They argue the big driver is the sun itself, its natural cycles, its large-scale magnetic flips, and the constant turbulence baked into the solar wind. In their view, comets are more like floating weather vanes. They trace what's happening, but they don't cause it. And honestly, that's how science works, right? You've got the modelers saying one thing, the observers saying another, and now the swarm of 2025 comets is basically the ultimate test case. We're going to find out in real time which picture is closer to reality. Here's the one thing everybody agrees on, though. Late 2025 is going to be nuts. CME rates are expected to spike to 2 to 5 per week during solar maximum. That's like the sun hurling out plasma bombs almost every other day. So whether comets are triggers or just test dummies, this is the perfect setup. Space weather officials are already prepping. NASA, ESA, ground-based observatories, they're lining up global monitoring campaigns. Even amateur astronomers are gearing up, ready with backyard telescopes and cameras. Citizen science is going to be huge. If one of these disconnection events happens while the comet is bright enough for the public to see, you could have regular people all over the world filming live evidence of solar physics in action. So the debate might be unresolved, but that's part of the excitement. Every camp has sharpened its focus. The swarm isn't just a cosmic show for stargazers. It's a real-time physics experiment being staged in our own solar backyard. Every new CME, every twist in a comet's tail during this swarm is like another round in a heavyweight fight between theory and reality. And the wild card in the middle of it all, that's 3I Atlas, the interstellar bruiser. When astronomers first plotted its orbit, they realized instantly, this thing does not belong here. Its trajectory is hyperbolic eccentricity well above 1. Translation, it's not bound to our Sunday. It's not coming back for a second lap. It's just barreling through like a hitchhiker from another star system taking a one-way road trip across our neighborhood. Only 2 other confirmed objects have ever done that. Oumuamua in 2017 and Borisov in 2019. But Atlas is bigger, brighter, and flat-out weirder. Early readings from Hubble and JWST bracket its nucleus somewhere between about 320 meters and 5.6 kilometers. That's a huge range, like the difference between a city block and Mount Everest. But the coma? That's the halo of gas and dust blasting off as it gets heated by the Sunday. That bubble has already ballooned out to nearly 700,000 kilometers across. That's Jupiter-sized. Let that sink in. A chunk of ice and rock, not even a mountain in size, is shedding enough gas and dust to make a bubble the size of a planet. And it's still growing. Every week the thing looks bigger. And the chemistry? Totally alien. Most comets we've studied out here have water ice as their main ingredient. This one? Its coma is dominated by carbon dioxide and other volatile gases, with barely any water vapor showing up. Cyanide, the classic signature we often see on comets, is only barely detectable. These fingerprints don't match the typical comets we've cataloged. It's like tasting wine and realizing, nope, this wasn't made from any grapes we've got here. This is a whole new recipe. And because it came in at a steep angle, just 5 degrees off the ecliptic, moving crazy fast, there's no doubt this thing was born around another star. Think about that. For billions of years, this rock orbited somewhere else entirely, maybe around a young star system that looked nothing like ours. And now, for a couple of months, it's cutting across our backyard before vanishing forever into deep space. That's cosmic history driving right past you. The stakes for science are huge. Every image, every spectrum we collect is basically a sample of another solar system's building blocks. If you want to know how unique Earth really is, this is the kind of evidence you need. And there's a bonus twist. When Atlas swings around the sun, it's leaving behind a trail of dust and debris. By 2026, Earth's orbit might cross that trail. That means planetary defense teams will get a rare chance to monitor interstellar debris hitting our upper atmosphere. Shooting stars from another star system, that's wild. Now, all of this is happening alongside the rest of the 2025 swarm, which means for the first time in decades, comet watching isn't just for hardcore telescope nerds. Regular people are going to get front row seats. Here's the calendar. It kicks off October 21st. Right before dawn. That's when C 2025 R2 Swan makes its closest pass just 0.25 AU, about 37 million kilometers from Earth. Not close in asteroid terms, but close enough for a naked eye show. With a decent pair of binoculars, you'll see its tail stretch out to 2.5 degrees. That's 5 times the apparent width of the full moon. Its head will glow at magnitude 6 or 7. Not dazzling, but visible. From most northern latitudes, it climbs to about 40 degrees above the horizon before sunrise. That's a sweet, clear shot for anyone willing to set an alarm and step outside. Meanwhile, 3I Atlas is ducking behind the sun at Superior Conjunction. You won't see it from your backyard then. But here's the hack. Go online. NASA's SOHO spacecraft has coronagraph cameras watching the sun 24/7. They'll catch Atlas and Swan skimming around the edges of the solar glare. These feeds are open to the public. Anyone with a browser can log in and literally watch in real time as an interstellar object brushes past the sunday. That's insane. Then by early November, another headliner arrives. C 2025 A6 Lemon. This one is the People's Comet. Forecasts say it could reach magnitude 4, maybe even 3.5, which means it might be visible to the naked eye from dark sites. You'll spot it low in the southwest just after sunset, brightening night after night as it approaches perihelion on November 8th. For most of us, this will be the easiest comet to catch in years. You won't need fancy gear. Just step outside, look up, and boom, you're seeing a traveler from the outer solar system glowing in your sky. The best dates? October 21st for Swan's flyby, then November 6th through 12th for Lemon's peak. Now here's the kicker. Predictions are just guesses. Comets are notorious for surprising us. Some fizzle out and disappoint. Others suddenly erupt and become spectacular. We've seen comets brighten by whole magnitudes overnight because of a crack in the crust or a sudden outburst of gas. No model can fully predict it. Grain size in the dust, the thickness of the surface crust, the exact way sunlight penetrates, it all adds chaos.
That's why forecasts can swing by 2 magnitudes or more. A comet pegged to peak at magnitude 3 might instead glow faint at magnitude 5, or a dull little snowball might suddenly flare and become the star of the season.
With Atlas, the uncertainty is even bigger. We still don't know the true size of its nucleus. The Hubble and JWST constraints give us a ballpark, but until it swings closer, the math is fuzzy. And with so little water vapor and so much carbon dioxide driving the outgassing, its behavior could diverge completely from the playbook of local comets. So yeah, even with the best thermophysical models, the only sure thing is expect the unexpected. And that's part of the magic. In 2025, for the first time in living memory, ordinary people around the globe will have a reason to step outside and look up, not just once, but night after night, to see cosmic visitors that may never return, to watch tails stretching across the stars, to witness the sun's storms literally slicing comets in half. And thanks to space telescopes and online feeds, we're all part of the observation team. Looking forward, the Vera Rubin Observatory, with its LSST survey starting soon, will catch more of these wild cards. It'll map the whole sky every few nights, spotting faint, fast movers that today we might miss. That means more interstellar surprises, more one-time visitors, more opportunities to compare alien material with our own solar system's recipe. But even with LSST, there's no substitute for being outside, seeing it with your own eye. That's what this 2025 swarm offers. Science, sure, but also wonder. It's a reminder that the solar system isn't static. It's alive. Stuff is happening all the time. And sometimes the cosmos throws us a curveball, 7 comets at once, including a Jupiter-sized interstellar coma, all while the sun is at maximum tantrum mode. for anyone alive right now, this is the season to remember.